river regimes and hydrographs. And you know what? This is the part 3 of river environment. So that means there's the part 2 and also the part 1. So go check it out. All right. Now we have to have actually an objective. What are we supposed to achieve at the end of this lesson? There we go. So by the end of the lesson, we should be able to know this. These are the things that we should know by the end of this lesson. The definition of river discharge, river regime, storm hydrograph, and lag time. So make sure you understand all these things by the end of this lesson. Also, you should be able to know the factors affecting river regimes, the precipitation, including storm hydrographs, temperature, vegetation, land use, water obstructions, and also actually dams, all right? So make sure you know all these things that you are seeing there. Understood? Now, let's start with the definition of terms. Let's start with river discharge. So when you hear of a river discharge, it's the amount of water carried by a river at any one time. So when you go to a river and you just find that amount of water, that very time, that is what we call a river discharge. As easy as that, okay? Then we go to river regime. Now, river regime, now we kind of focus on the variation. How is it varying over some time? Understood? So like the variation, today maybe it's the volume is less, tomorrow it will be higher. That variation over time is what we call river regime. Understood? Okay, then we talk about a hydrograph. A hydrograph is actually a graphical representation of a river regime. Because we've said is a graphical representation of the variation in river discharge over time. And the variation in river discharge over time is what we call a river regime. Understood? So a hydrograph is now a graphical representation of that river regime, which is the variation in river discharge over time. So when you take that river regime and then you present it in a graph, that's what we call a hydrograph. I think it's so clear. Now we talk about a storm hydrograph. Now this storm hydrograph is actually a hydrograph, but now in response to a rainfall or a storm event. This is what I mean. It's a graphical representation of a river regime in response to a rainfall or even a storm event. Okay, now that's why I'm saying that it's a graphical representation of the variation in river discharge, which is the river regime, over time in response to a rainfall or storm event. So maybe you have an event of a rainfall, and then we look into the variation of that river, or even that drainage, that river, the behavior of that river, and then we give the details. So we are kind of comparing that variation of that river discharge over time, but now we are responding to a storm event or a rainfall event. Understood? Now, the last thing that I want you to understand in terms of definition of terms is lag time. What is it? Okay? The lag time, what is it? Now, we get to know about lag time when you're talking about maybe a storm event or a rainfall event. For example, there is a rainfall has fallen, and then we've had the peak discharge in a river. Okay, and also when rainfall is kind of falling, we're going to have that time that where we are having the peak rainfall. Understood? Because you'll have maybe a graph, then as the rain is falling, there's a point you'll have the peak rainfall, okay? And also there's a point whereby we'll be having the peak discharge in that river. And remember, we talked about the peak discharge being the amount of water carried by a river at that one time, okay? So the difference between that peak rainfall and the peak discharge is what we call the lag time. Understood? That's why I've said that it refers to the delay between a rainfall event and the corresponding peak flow or discharge in a river. Okay, so it represents the time it takes for water to travel from the point of rainfall to the outlet of a watershed or river basin. Okay, I think it's clear. So it's often calculated by determining the time difference between the peak of the rainfall event and the peak discharge in a river. All right, and it can be expressed as the time it takes for the hydrograph to reach its maximum. So that difference between the peak rainfall and the peak discharge in that river, the time, the delay between is what we call the lag time. Now look at this diagram. Okay, these are storm hydrograph because we are looking at a river regime, but now in response to a storm event, right? That's what we call a storm hydrograph. Now look at this. We are having rainfall here because we are talking about rainfall. So this graph here is represent the rainfall, and you've seen that at this time the rainfall was below 10 millimeters. This was just above 10 millimeters, and this was the peak now where we had around 50 millimeters, and then we had these around 45 millimeters. Then this one like that. So you see, this is where we are having the peak rainfall. Okay, and then look at the river discharge. Remember, the river discharge is the volume of that river at one time, okay, in that river, all right? So the river discharge, the river volume is kind of rising, okay? But there's a time where it reach at the peak before it start falling. So this is the peak discharge here. And here is the peak rainfall. Now the time it takes from this peak rainfall to the peak discharge is what we call lag time. So this time you're seeing here is what we call lag time. Understood? And now what do we call this? We call these as we refer to these as the rising limb, meaning it's rising. Okay, the volume of that river is kind of rising. The river distance is kind of adding. Understood? Then it reaches at a point where we are having the peak, and then it starts falling. So we call this part here the falling limb. This one the rising limb. This other one the falling limb. Understood? And this one is the normal, the base flow. Okay, the base flow. That's what we call it. So in case maybe in an exam you're asked the part marked, maybe this part, this is the peak rainfall, this part the peak discharge, but when they say this time and this the time in between, that's the lag time, and then the falling limb, rising limb, just like that. Understood now? Very good. So make sure you know all those definition of terms. Okay, all right, let's look at this. A short lag time will cause the river discharge to rise steeply. Why? Why do you think so? A short lag time will cause the river discharge to rise steeply. Think of a scenario where you're having like the peak rainfall and the peak discharge is very, very short. What will be happening to the river discharge? To rise steeply. Okay, because when you're having the peak discharge and the peak rainfall is kind of short, that time in between is short, then the volume of water will kind of rise steeply. I think it's so clear. But when it will be taking time, you see that water will kind of be having time to flow. All right. But when that time is short, it will kind of rise. The discharge of that river will kind of rise. But when it will be kind of long, it will be taking a lot of time. Water will be finding its time to flow. You see now, it won't rise steeply. The discharge of that river won't rise steeply. So when you see a short lag time, that means the river discharge is rising steeply. And then you know what that can cause. It can cause floods. Think in that order. Okay. And then when we have the steeper the rise in discharge, the greater the chances of flooding. That's actually what I've talked about. It's clear? All right. So lag time is important in flood forecasting because when you know that there's a very short lag time, you can be able to predict flooding might be happening. So understanding lag time will kind of help you in understanding lag time is kind of crucial for predicting and managing floods. Okay, that means that longer lag times may provide more lead time to flood warnings and preparedness. When you see that it's kind of having a long lag time, what do you think is going to happen? Kind of people will get that time at least to prepare themselves, just to avoid the floods, and also they can get that enough time to be warned that maybe a flood is going to take place when we have that long lag time, because it won't cause the river to rise steeply. Okay, I think you understand that point. Then quick urban runoff with short lag time can contribute to flash floods. Okay, when the lag time is short, you know what that means? Will cause that water kind of to rise. The river discharge will kind of rise steeply, and that will cause actually flash floods, especially in areas with impervious surfaces. Impervious surfaces are impermeable surfaces that cannot allow water to kind of infiltrate, or the surfaces that cannot allow water to kind of sink into. Understood? All right. Now, look at the factors affecting river regimes. You should know this. It's very, very important. And remember, when we talk about river discharge, river regime, they're kind of the same thing, okay? Because river regime, the variation of that river discharge. River discharge, the volume of water, okay, at a given time. Understood? So let's talk about the factors. So when you talk about these factors, they can be affecting both the river regime and also be having an influence in the river discharge. Understood? Now look at that. The amount and the intensity of the rain. Okay? Understood? So what do you think? When we have heavy rain, it will actually not sink into the ground. When we have that heavy rain, it will be kind of become an overland flow or runoff and quickly reach the river. Remember, when you're talking in part 2, kindly, if you've not watched the part 2 of this video, go watch it out, because that's where we began from. Okay, if you need to understand well and you go step by step for you to understand this topic of river environments, kindly make sure you watch all the other parts so that we can be together and understand everything now. So when you talk about surface runoff, okay, that water that kind of run on the surface. So when we have that heavy rain, it won't sink into the ground. It will just become like overland flow, and it will quickly reach the river. Understood? So it's kind of going to increase the river discharge in that river, and that's the factor that is affecting river regime. And because river regime is the variation of that river discharge over time. Understood? Then we talk about temperatures. What do you think of temperatures? So temperatures will affect the form of precipitation. Remember, precipitation is one major thing that kind of affect river regimes. So temperatures will affect precipitation. For example, if temperatures are below freezing, precipitation will be the form of snow. Okay. If temperatures are below freezing, precipitation will be in the form of snow. So this can take weeks to melt. You know that? If temperatures are kind of below freezing point. Okay. Precipitation will be in the form of snow, and it can take quite some time to melt. So if the ground remains frozen, melting snow on the surface can reach the river quickly, and you know that is going to increase the river discharge. If it reaches the river quickly, going to increase the river discharge. So that one is a factor on its own. It affects river regime, the temperatures. Now look at these other ones, steep slopes. What do you think? When you have steep slopes, what will be happening? Water will be kind of flowing very fast to the river, as easy as that. So it will cause rapid surface runoff. So this will cause the river discharge kind of to rise steeply. You know what that can cause. So flat and gently sloping may lead to water sinking in the soil, because it will be kind of taking time. So it will be having that time to sink into the ground. All right. So this will delay water into reaching maybe that river. Understood? So the river discharge will kind of not rise steeply. It should kind of slow in terms of rising. Okay. Now let's look at another one, which is the rock type. What do you think about rock type? Remember, we have different types of rocks. There are rocks that can allow water to pass through. There are rocks that cannot allow water to pass through. Rocks that can allow water to pass through, we call them impermeable, rocks that cannot allow water to pass through, we call them impermeable rocks. But those that can allow water to pass through, we call them permeable rocks. So if the rock is impermeable, what do you think will happen? Water won't be sinking, so it will flow fast to the river. And that is going to have an effect on river regime. Understood that? Because it's going to cause that rise in river discharge. And it's going to have an effect on river regime. Don't forget, river regime is the variation of a river discharge. Understood? Or the variation of volume of water over time. Understood? So impermeable rocks will not allow rainwater to pass into, so will speed up runoff. So permeable rock allow infiltration and percolation of water in the bedrock. This in turn slows the delivery of water to the river. Okay, so permeable rock will kind of slow uh, the rise of that water. It kind of be taking time, okay, because water will be taking time to sink into the ground. That's the rock type. Then we have another one, vegetation and land use. In dealing with the drainage basins, we talked about vegetation. Not really. Yeah, drainage basins. We talk about vegetation, kind of intercepting water from reaching the ground. Okay, so when you have vegetation, the stems, the leaves can kind of intercept that water from reaching the soil. Understood? So trees and other plants intercept and delay the rain reaching the ground. Okay, see that? So when you have trees, we kind of delay that rainwater from reaching the ground because it will be intercepting like preventing that water from falling to the ground. So you're kind of delaying that runoff or delaying that water flow that will be kind of flowing to the river that can increase the river discharge. But now it is intercepting that water, okay? And then when now the trees are kind of cut down, when we have now bare soil with no trees, what do you think? It will speed up runoff. Why? There's no trees to intercept, there's no trees to kind of prevent that water from sinking the ground. Understand that? So it will not reduce that time. Actually, it reduce the so bare soil and rock speed will kind of increase that speed of river discharge. Why? Because it will take a very short time, meaning that a very short time to reach the river, because it will kind of be flowing fast in the river, in that there is nothing that is delaying that water, so it kind of reduces that lag time, and you know that can cause steep increase of river discharge. So two will urban areas, actually when we talk about urban areas, land use, when you talk about land areas, they have a lot of paths that are kind of built up, concrete paths, okay. The build is there, they're kind of not allowing water to pass into the ground, so it will kind of increase that speed of that runoff, okay. And then the speed of that runoff is increased, you see that time between the peak and the peak discharge is kind of reduced, so that lag time is shortened, and that will kind of increase the river discharge. Understood? All right, human intervention. When you talk about human intervention, we mean that the human activities that are kind of can kind of influence or can kind of cause some changes into these river regime. Okay, think of it this way. Maybe you've there's that building of things like dams. Okay, understood? We built a dam. You see, you can control that water. You know that? So dams and reservoirs, these are things that human kind of intervene. So dams and reservoirs are an obvious form of intervention in river regimes. So by holding back discharge, dams reduce risk of flooding downstream. So they can actually control that river discharge. They can decide to hold the water, and then they can decide to open for that water to pass through. You see that? So that is a human intervention. It's going to have an effect. It's the actual factor that will influence river regime. So the flow of water out of reservoirs can also be controlled by opening and closing sluice gates. Remember, we have things like sluice gates, whereby you can actually open. It's like a water gate. You can open that gate for the water to pass through, and then you can close to prevent that water from passing through. That one can control actually that issues of flooding. Understood? All right. So if you've understood that, we can now revise the commonly asked questions. Actually, I've picked some of the questions that are not even some, almost all that have been said from 2017 up to 2023. So I hope you are following cleanly. Let's revise this. All right. So explain one way vegetation can affect river discharge. Guys, we've just done this lesson. I hope now you have it in mind. What do you think? Ah, bravo for those who got it right. Vegetation, know what that cause, okay? So, a lack of vegetation, we talk about lack of vegetation and we talk about uh, availability of that vegetation, they have an effect either way, okay? Lack of vegetation, you know what it can cause. When there's that vegetation, you know what that can cause, okay? Talk about interception. So, let me look at this answer. Lack of vegetation exposes bare rock and soil, okay? So it reduces the time taken for water to be soaked up. That is overland flow, okay? So it reduces that time taken, okay? Because the soil is kind of exposed. Now it will reduce the time taken for water to be soaked. So it will kind of flow, okay? It won't take time actually. It will kind of flow directly to the river. So that means it will increase the river discharge. Understood? When there's no vegetation, water will kind of flow very fast to the actually say that the surface runoff will kind of increase to the river because there's nothing that is kind of holding that water that can make it maybe infiltrate or even sink into the ground. Understood that? So it will shorten the lag time, and you know, shortening the lag time will kind of increase the river discharge. Understood? Then when you have trees now, they can intercept actually. So trees and other plants intercept rainfall. So this delays the rain water reaching the ground. Understood? So that where there is now trees, it can kind of delay that water from kind of flowing into the river. So it kind of intercepting the water and then can actually find time to sink into the ground actually because it's kind of delayed, right? And then resulting in lengthening of lag time because now because of that delay, the lag time will kind of be kind of lengthened, right? When you have that, it will reduce river discharge. I think it's clear there. All right, we go to another question. Identify the meaning of the term river discharge. That is easy, guys. So from the choices, you can get one there. What is the right response? Okay, the average speed of water in a river at one place at one time. Is it the answer? You're talking about speed here, so it can never be the answer. The volume of water in a river at one place at any one time. Is it the answer? It is the answer because you're talking about the volume of water in a river at one time because it has river discharge. River regime, remember the variation of that volume of water at one place over time, okay? But this one is at one time. But river regime, the variation over time of a river discharge over time, okay? So the average depth of a river, we're talking about depth, so it can be true. The average width, we're talking about width, it can be true. Okay, so the right response is B, the volume of water carried by a river at any one place is the correct response. Then we go to state one physical factor that affect river discharge. Physical factor that affect river discharge. State one physical factor that affect river discharge. What do you think? Any factor that you think a physical. Don't talk about human factors. No, talk about the physical factors. Okay, the natural factors. What do you think? Some of these physical factors that are kind of affect river discharge. Okay, we've talked about them just before. Actually, these are the factors that are kind of affect river regimes. Now, look at that. You can have rainfall, maybe the high amount of rainfall. We kind of will kind of not find enough time to sink into the ground, so it will kind of flow fast to the river and then cause what? High discharge, cause the river discharge rise steeply. Okay, and that can cause flooding, such like. So it kind of reduce when you have high amount of rainfall. And the opposite is true. Vegetation interception, you remember that? The soil type, we have impermeable rock, we have a soil that can allow water to pass through, soil that cannot allow water to pass through. Okay, or sometimes we can talk about soil that is maybe saturated, that has a lot of water that can't allow actually more water to be absorbed. it kind of increase surface runoff that can reduce that lag time and then increase the river discharge. I think it's clear. So the depth of water or width of the river, I think it's clear. Then drainage density or number of tributaries, the density of river. We talked about this in the when you talk about drainage basins. Okay, that is in the part 2. Okay, so go look it out. So all these, when you write one physical fact that you feel it can affect river regimes, then you're going to get it right. All right. We have others: channel gradient. Okay, geology, velocity. I know we are going to discuss more of this, but these are one we were just supposed to mention. But I know we are going to meet more of these into other questions. Then we look at these other questions. Explain the term lag time. What is it? Lag time. You remember that? Bravo if you got it right, because this is the time between the delay between peak rainfall and peak discharge. So that time in between, the lag time. On the diagram, you remember I show you that. So I think it's clear there, right? So from this, the lag time is the delay between the peak rainfall and the peak discharge. You get your 2 points. All right. And then rainwater is delayed in reaching the river due to interception from trees. If you can maybe go ahead and say that, it's okay. But the lag time is the delay between peak rainfall and peak discharge. From the diagram, I think it was clear, right? Then we talk about the study figure 1A in the resource booklet suggests 2 reasons for the different storm hydrograph shapes. All right, 4 marks. Okay, you study the figure. What is that figure? Let's look at the figure. It's here. All right. Now you're supposed to study this figure in the resource booklet, and then you suggest 2 reasons for the different storm hydrograph shapes. Now look at these first storm hydrograph, because this is a storm hydrograph. We have a rainfall event here, or you can say a storm event here, and then we have the volume of water kind of changing. Okay, so this is a graphical representation actually of river discharge in response to a rainfall event. So these are a storm hydrograph. From the definition, I think you remember. Now, when you talk about this is a storm hydrograph in an urban area. All right, this is a storm hydrograph in a rural area. Now, why are they different? Look at this. What is different here? Look at this and look at this. The rainfall is actually almost the same. Yeah, it's almost the same. But now, when you look at this, the volume of water in urban area, the volume of water here is kind of different. Okay, this one here, the volume of water has kind of risen very fast. Okay, it has risen very fast, and then it has gone so high to an extent of 45, that is millimeters. Okay, no, not really 4 millimeters. There is the river volume. Okay, this line here represents the river volume, and also this one is kind of low. Okay, the river volume is kind of low throughout. It's not that fast and steep. Okay, not rising that steeply, kind of rising slowly. All right, so that's the difference actually, because we are now told to suggest reasons, actually 2 reasons for the different storm hydrograph. So something I've seen here is the issue of the river volume. Okay, the river volume. So what are these reasons for this? Now, this is an urban area and this is a rural area. What do you think is there in an urban area? And what do you think is there in a rural area? In an urban area, just think of it. We have concrete pathways. Actually, deforestation has happened there, so the soil is mostly bare there. Okay. We also have build-up areas, such like things. Okay. And then we talk about rural areas. We have a lot of vegetation. Just from what you know about rural areas, you have a lot of vegetation. So meaning there's things like a lot of trees there that can intercept that water. Understand? Because whatever is different here is a kind of the river volume. The in urban areas is kind of steep, is kind of high, as compared to rural areas is kind of short. Okay, when you compare the lag time between this and this, the lag time here is short because this is the peak discharge and this is the peak rainfall. So the lag time here is short. But compare these and these. Lag time is higher. So these are the differences. So what are the reasons? Now I think you have an idea of what is needed here. All right. Now, have you given your answers before I give mine? If you got them right, bravo. Now, actually, we can talk in both ways. There's a short lag time in urban areas. That's the difference. Why? Because of concrete paths. Why? Because the concrete paths will not allow that water to infiltrate. Okay, so water will be flowing faster into the river, and that kind of shorten the lag time, and you're there. So we also have a short lag time in urban areas due to steeper slopes. Okay, we can be having these are some of the things that can cause the lag time to be shorter. Okay, things like steep slopes, because water will be flowing very fast to the river, and then we'll reduce that lag time, the delay between peak rainfall and peak discharge. Understood? So when we have that kind of things, then that is a short lag time. That is the difference, and the reason is because of the steep slopes, because you are told to explain the difference. Okay, you give reason for the difference of these two storm hydrographs, and then talk about difference in rising limb. Think of rock type. It's actually one of the factors that can cause that difference in river lag time. Okay, when you have maybe a rock type that is kind of permeable and impermeable, so difference in rising limb due to rock type or land shape. Okay, then now you come to talk about longer lag time in rural areas, because that's what actually we've seen there. Okay, we have a longer lag time, if you see that. Why? Because vegetation intercepts rainfall. I've talked about that, it's clear. Okay, then we have longer lag time in rural area due to water taking time to infiltrate through the rocks. So you've explained the reason as to why maybe it's having a long lag time, which is causing the difference, and now the reason you've given there, so you get it right. So here you're supposed to identify the difference of that, the difference that is observed there, and then you give a reason to start. That's what the question was requiring. Understood? Now, let's go to another question. Study figure 1A in the resource booklet. Then you suggest two physical factors that affect these differences in lag time. So you should look at this figure 1A in the resource booklet. Let's look at the figure. Voila, it's here. It's actually the same as the previous one. I think, yeah. It's actually the same. And then now the question is, you suggest two physical factors. Please always read the question very carefully. You understand what they want. So suggest two physical factors. Physical, okay? Factors that affect these differences in lag time. So we have difference in lag time here. Actually, it's clear now that we've actually talked about similar thing the previous question. Also, we have this lag time here. This one is short, this one is long. So you suggest two physical factors. What are those two physical factors that kind of affect these differences? That's almost the same thing. It's only that I've got it from another paper that is kind of not the same question, but is a different. But now here you're just supposed to suggest two physical factors. Those are some of the factors actually. Think of the factors that can cause these differences in lag time. We have steep slopes. We have maybe vegetation. Okay, maybe deforestation was happening in urban areas, so we don't have that reduce lag time. Okay, we don't have that long lag time in urban areas because of maybe deforestation that happened. Maybe we have permeable rocks. In urban areas, of course, we have so many impermeable rocks because of the build-up areas, all the concrete pathways, such like things, the tarmacs. Understood? So that's what happens in the urban areas. That it actually reduces that lag time, because it will kind of make that water to flow very fast to a river, and then now the lag time will be reduced, and that can cause actually flooding. So there's a physical factor. We have impermeable rocks. Okay, impermeable pathways, impermeable This is one factor. But now we're talking about physical. We're talking about physical, such like. So I hope you have an idea of what we want here. All right. Now look at the answers. Steep slopes, they create rapid runoff and short lag time. Is that? Well explained. Rock type with permeable, okay, with permeable rocks allowing infiltration, increasing lag time. Because when infiltration is happening, water will be taking a lot of time to kind of when water will be in sinking, okay, into the ground, it will be taking a lot of time, okay, and that now will kind of increase that lag time. It won't shorten it because it's taking a lot of time infiltrating the ground, and then now that time between the peak and the kind of increased, and that is going to reduce the river discharge actually, because of that increased lag time. I think you should understand this very clearly. Then we have the size of drainage basin. That is with larger drainage basin leading to increasing lag time. Size of drainage basin. When you have actually, I told you when you were mentioning, just listing the factors that are kind of affecting river discharge. Where I talked about size of drainage basin, I said we are going to talk about it more when we reach it later question, and here we are now. Size of drainage basin with larger drainage basin leading to increasing lag time. When you have a drainage basin that is kind of big or even large, what do you expect? The lag time will be increased because that peak discharge won't be easily reached. It will be taking a lot of time for the peak discharge to be reached. So the lag time is going to be increased. I think it's clear. Then vegetation will increase the time it takes water to reach the river because of that interception. Saturated soil, when the soil type is kind of saturated, so it won't be a saturated soil that cannot like actually it's kind of wet already to an extent it can't take any more water, so it will kind of increase runoff because it does not allow now water to stay within it, so it will kind of increase the runoff, and that will shorten the lag time. So we can accept any other appropriate response, bora you make the right response. Then another one, explain how urban land use can affect river regimes. We've talked about that severally. Urban land use usually increases the amount of land covered by impermeable surfaces, which means increased runoff when it rains, which can lead to a river regime with higher chance of floods. That is very clear. When you are explaining, please expound your answer, explain like fully. Okay, urban land use, what can it do? It can increase the amount of land covered by impermeable surfaces. And then what happens? Remember, you're explaining, you want to scoop all the marks, okay? Which means, okay, it has increased impermeable rocks, and then it means that increased runoff when it rains, because when it increases impermeable surfaces, it will kind of increase runoff when it rains, which can lead to a river regime with higher chances of floods. Understood? If you want to talk about lag time, talk about it there, because it can shorten the lag time, which can increase the river discharge, which can cause floods. All that well understood. Then urban land use can lead to deforestation, okay, because deforestation is happening for the build-up areas to be set in place, so which reduces the amount of interception for vegetation, which means the regime can be more flashy. It's clear? All right. Now, study figure 1b in the resource booklet. Identify the feature of the storm hydrograph labeled X. Let's look at that resource booklet. Okay, look at that. You talked about this in the notes. Now, what is this? And I'll ask you too, what is this? And then I'll ask you between this and this, what is the time in between here? Okay, so what is this part? Bravo, if you got it right. So this is the peak rainfall, and then here you have the peak discharge. This time from here to here, the time in between will be the lag time. This is the rising limb. There is the falling limb. If you have maybe another line here, maybe indicating something like a normal flow or base flow, such like things. As easy as that. Is it hard? It's not hard, guys. Then we talk about, okay, the answer is peak rainfall, okay? It's clear there. Then identify one physical factor that affects river regimes. Talked about this severally. One physical factor that affects river regimes. Talk about amount of rainfall. It's actually an answer. Building a reservoir. We're talking about physical. Okay, it's physical there, but it's a human factor. But it's an answer, but it's a human factor. Okay, then building a football stadium, actually it's also a human factor. Size of river mouth, no. So the answer is amount of rainfall. The answer B, C are human factors. Understood? Then explain one way precipitation can affect river regimes. Precipitation, what do you think will happen there? So high intensity of rainfall doesn't soak into the ground. Okay, when you have amount of rainfall being high, it won't allow water to pass sink, so it will kind of reduce that lag time, and that will increase the river discharge, because when the lag time is shortened, the river discharge is kind of increased, it rises steeply. Then amount of rainfall, as heavy rainfall will saturate the ground. Okay, the amount of rainfall, as heavy rainfall will saturate the ground quickly, resulting in higher levels of runoff, shortening lag time. Amount of rainfall, high intensity of rainfall, amount of rainfall is actually almost the same thing. Okay, so make sure you explain well, and then explanation, please let me be clear here. Explain fully. Explain something, mention that thing, explain how it's causing that, and then explain what it will cause that, what will be the result after that. Okay, so you could develop reverse ideas like limited rainfall. Remember, you can be talking about high rainfall and then talk about limited. Okay, either way you get an answer. So regime is about the whole, but so accept reference to either river regime or storm hydrograph. Okay, now let's look at explain one way urbanization can affect river discharge. These are build-up areas. Urbanization, remember that? Okay, it's clear. Increased urbanization can increase rates of surface runoff, because it will increase the kind of impermeable surfaces. Okay, so we usually decrease the lag time and increase the peak river discharge, which is so clear. And then less interception by trees, because in urban areas we don't have a lot of trees, so kind of soil is kind of bare, so it will kind of reduce the surface, reduce the lag time, which can increase the river discharge, which is clear. Explain how one physical factor can affect river regimes. This one talked about severally. You can say steep slopes, impermeable rock, climate change. Okay, all these, and then you explain very well as you've talked about there, and then you're good to go. As easy as this. So you've seen questions that come with this subtopic of the part 3. Okay, so that means part 2 we had also their questions, and then when you revise this, you will never fail any question actually in river environments. Now look at the study, look at the figure 1C in the resource booklet, and then you analyze the factors that affect the river regime. Okay, you know them actually, but now here we are instructed to look at the resource booklet in the figure in the resource booklet. Okay, and then we analyze these factors that affect these river regimes. Okay, now look at that. These are watershed. So this means that these are a drainage basin, a river, kind of a river. Then these are tributaries, I think, and then we have this forested area from the key here, and then we have this part A and this part B. Okay, part B we have some forested area. Part A we have kind of pastoralism taking place. We have what is this? This is an urban area. So it's this kind of urban area, and this kind of a rural area. If that is the case, okay, I saw that sure, but you can see this is an urban area. This area A is kind of an urban area. Area B is kind of rural. That is my perception of this resource booklet. I don't know what you can perceive. And then you come here. Oh, this is a hydrograph gauging station, and you see that hydrograph gauging station is where river discharge is measured. So this is the river discharge actually in station A. This is the river discharge in station B. Okay, so the river discharge in station A is kind of the river volume has kind of increased so much. In fact, it's kind of high. Okay, the river volume has increased very fast here, because they've gone to a level of 70 millimeters there, the river discharge, cubic centimeters I mean. And then we have this, see this, it's kind of low. Okay, this is for B. Okay, what do you think? Are you getting an idea what is happening there? So this is a forested area. It's kind of rural actually, so we can actually argue in terms of this. So these are watersheds, so this means the river drainage basin. So you are told to analyze. Okay, when you are told to analyze something, a question in geography, especially the igcse that I'm dealing with, make sure you kind of it's like you are kind of discussing that question. Okay, you're kind of discussing it with maybe your friend, but now in writing form. So discuss, don't write the friend and no, just talk about everything about whatever the question is asking about. So when you talk about the factors, like the factors that affect the river regimes, talk about what a river regime is, because you're analyzing this. Okay, talk about what a river regime is, and talk about some of the factors that affect this regime, and then explain all those factors, and then refer all these factors that we've talked about to what is there in the resource booklet. Prove from the resource booklet, is it mentioned? And then by doing that, you are kind of going to get your whole 8 marks, because you've discussed everything. That's an analyzing question. Make sure you discuss everything. You start by at least making us know what is this river regime, and then we are told like the factors. What are these factors? Just mention them, and after that you talk about now one by one. Like this one, how is it like this? You explain what it costs, how it is cost, and then the result of that. All right. Now let's look at some of my answers. So when we talk about maybe the marking scheme, normally the marking scheme that is being provided actually is not kind of prescriptive. When I say prescriptive, I mean like it's not kind of a guide to make sure that the learner write whatever is in the marking scheme. No, here you are open. Bora, you are supposed to kind of make sense. Okay, make sense and explain what you are told to explain. Actually, that's what I mean. All right, it's kind of an advanced way of explaining that question. Explain and analyze. You're kind of analyzing these and these and these, but you explain something. You are talking more about that something, that thing. Okay. Now let's look at some of the answers that I expect. So a river regime, you have to start by telling what it is. It's the way in which the river changes over time. So the factors affecting river regimes can include, you mentioned them. So in areas with a lot of trees, you can now start kind of analyzing one by one. Okay, urbanization. You see, I've talked about precipitation, temperature, vegetation, land use, water obstructions, and dams. Okay, these are some of the factors that kind of affect river regimes, of which we've talked about them severally. So you can say in areas with a lot of tree coverage, there will be greater interception of rainwater. Okay, actually we're dealing with vegetation here. Urbanization is associated with the more flashy river regimes due to. So you see in the resource booklet here we have some kind of two things. We have this forested area, and then we have an urban area. These are two things that at least you have to start with, because they're approved actually from the resource booklet. Okay, and it's here now. So in areas with a lot of tree, what do you think will happen there? And then you explain fully what is going to happen there. The urbanization is associated with more flashy, that's than the part of urbanization. Okay, so river regimes can also, remember you are kind of analyzing. Okay, so don't just stop there, talk about something, not even if it's not in the resource booklet, but at least explain more. You're analyzing this. Okay, river can also be affected by human intervention. Is it there in the resource booklet? No, but you are kind of analyzing the whole question. Okay, so talk about all the things that you feel can be answering that question, and then by that you liaise the question to the resource booklet, because you can actually prove from the resource booklet. Figure 1C shows how a drainage basin can include a range of rivers which connect to each other, each with which may travel through different. So figure 1C shows river traveling through the areas of forested land used for pastoral farming. Has okay. So when you are giving your answers, kind of explaining, you can actually mention that proof. You can give that proof from the resource booklet, guys. I think that is so clear. And now we call these we refer to these as the end. Understood? And now that means you should watch out part 4, because it's the next thing and it's ready already, ready to be uploaded. So thank you. Have a nice time.